At the end of this video, you should be able to list and compare the distinctive properties of ionic and molecular compounds and write the Lewis structure for a polyatomic ion given the identity of the atoms combined and other appropriate information. Chapter 6, Section 3, a comparison of ionic and molecular compounds. The force that holds ions together in ionic compounds is a very strong overall attraction between positive and negative charges. In a molecular compound, the covalent bonds of the atoms making up each molecule are also strong. But the forces of attraction between molecules are much weaker than the forces of ionic bonding. This difference in strength of attraction between the basic units of a molecular and ionic compound give rise to the different properties in the two types of compounds. The melting point, boiling point, and hardness of a compound depend on how strongly its basic units are attracted to each other. Because the forces of attraction between individual molecules are not very strong, many molecular compounds melt at low temperatures. In fact, many molecular compounds are already completely gaseous at room temperature. In contrast, the ions in ionic compounds are held together by strong attractive forces, so ionic compounds generally have higher melting points and boiling points than do molecular compounds. Further, they do not vaporize at room temperature as many molecular compounds do. Ionic compounds are hard but brittle. Why? In an ionic crystal, even a slight shift of one row of ions relative to another causes a large buildup of repulsive forces, as is shown in figure 6-17 on page 179 of your text or on the screen now. These forces make it difficult for one layer to move relative to another, causing ionic compounds to be hard. If one layer is moved, however, the repulsive forces make the layers part completely, causing ionic compounds to be brittle. In the solid state, the ions cannot move, so the compounds are not electrical conductors. In the molten state, ionic compounds are electrical conductors because the ions can move freely to carry electrical current. Many ionic compounds can dissolve in water. When they dissolve, their ions separate from each other and become surrounded by water molecules. These ions are free to move through the solution, so such solutions are electrical conductors. Other ionic compounds do not dissolve in water, however, because the attraction of the water molecules cannot overcome the attraction between the ions.
Particles in ionic compounds are held together by electrostatic attraction, forces that result from the transfer of electrons between atoms to form ions. In table salt, each positive sodium ion is attracted to the negative chloride ions that surround it. Negative chloride ions are separated by positive sodium ions to which they are attracted. The combined electrostatic force holds the ions together to form compounds. Because the attraction is strong, ionic compounds tend to have high melting points. A lot of energy is required to overcome the attraction between the ions. In molecular compounds, the atoms are held together by covalent bonds, bonds in which the electrons are shared. The attraction between covalently bonded atoms is not as strong as the attraction between ions. Because of this, molecular compounds, such as sugar, tend to melt at lower temperatures than ionic compounds, such as salt.
Polyatomic ions. Certain atoms bond covalently with each other to form a group of atoms that has both molecular and ionic characteristics. A charged group of covalently bonded atoms is known as a polyatomic ion. Polyatomic ions combine with ions of opposite charge to form ionic compounds. The charge of a polyatomic ion results from an excess of electrons, negative charge, or a shortage of electrons, positive charge. For example, an ammonium ion, a common positively charged polyatomic ion, contains one nitrogen atom and 4 hydrogen atoms and has a single positive charge. Its formula, NH4+, sometimes written in brackets to show that it is a group of atoms and as a whole has a charge of 1+. The 7' protons in the nitrogen atom plus the 4 protons in the 4 hydrogen atom, plural atoms, give the ammonium ion a total positive charge of 11 plus. An independent nitrogen atom has 7 electrons, and 4 independent hydrogen atoms have a total of 4 electrons. When these atoms combine to form an ammonium ion, one of their electrons is lost, giving the polyatomic ion a total negative charge of 10 minus. Lewis structures for the ammonium ion and some common negative polyatomic ions, the nitrate, sulfate, and phosphate ions, are shown on page 180 of your text or on the screen now. At this point, you should be able to list and compare the distinctive properties of ionic and molecular compounds and write the Lewis structure for a polyatomic ion given the identity of the atoms combined and other appropriate information.